Hello, this is lesson 1.4, a first look at functions. A function is a sequence of statements designed to do a particular job. You already know that every program must have a function named main. However, most programs have many functions and they all work analogously to main. Often your program needs to interrupt what it is doing to temporarily do something else. You do this in real life all the time. For example, you might be reading a book when you remember you need to make a phone call. You put a bookmark in your book, make a phone call, and when you're done with a phone call, you return to your book where you left off. Now, C++ programs work the same way. A program will be executing statements sequentially inside one function when it encounters a function call. A function call is an expression that tells the CPU to interrupt the current function and execute another function. The CPU puts a bookmark at the current point of execution and then calls or executes the function named in the function call. Now, when the call function terminates, the CPU goes back to the point it bookmarked and resumes execution. Here is a sample program that shows how new functions are declared and called. Include IOStream. Now don't forget, for Visual Studio users, you need to include stdafx.h before the IOStream. So let's go ahead and before the main, create a function called doPrint. We will do something like that. Void doPrint. Okay, in it we will use namespace std and then we will cout in doPrint. Something like that. Excuse me, and line. Okay, so right here is the declaration of the function doPrint. Let's do it with capital D and D. Okay. Now, in the main function, we will again say using namespace std cout starting main and line, then doPrint, then cout ending main. Okay, and return 0. Now, if we run that program, we will see the following output. Starting main, in doPrint, ending main. Okay. So, this program begins execution at the top of the main. And the first line to be executed prints starting main. The second line in main is a function call to doPrint. At this point, execution of statements in main is suspended and the CPU jumps to doPrint. The first and only line in doPrint prints in doPrint. Now, when doPrint terminates, the caller, which is the main function, resumes execution where it left off. Consequently, the next statement executed in main prints ending main. Functions can be called multiple times. For example, instead of just doing doPrint once, we could do doPrint, and doPrint 3 times. And you know what, let's just call it doPrint2 for the sake of another example. And we're going to call this function in doPrint2, which is going to print in doPrint2. If we run this program and see the result, we will see the following output. Starting main, in doPrint2, in doPrint2, in doPrint2, and then ending main. In this case, main is interrupted 3 times, once for each call to doPrint2. Now, main isn't the only function that can call other functions. So take a following example where our function doPrint calls a second function doPrint2. In this case, we will get back to our void doPrint using namespace std cout end doPrint. And line. And let's say, okay, I'm going to type that doPrint below the doPrint2. I'll explain that later, why I did that. doPrint. So in doPrint2, I am printing in doprint2, and in doprint not only do I say, let's say, starting doprint, but I will call doprint2 twice, and then print ending doprint. Okay, in the main I am just going to call doprint once. Let's see what that happens. So if we run that, we will read the output. Let me get that higher. Okay, starting main, starting doprint, in doprint2, in doprint2, ending doprint, and then ending main. So if you remember, when main finishes executing, it returns a value back to the operating system, the caller, by using a return statement. Functions you write can return a single value to their caller as well. When we do this by changing the return type of the function in the function's declaration. A return type of void, like the following examples of doprint and doprint2, means the function does not return a value. A return type of int means the function returns an integer value to the caller. So, let's take this following example. Void return nothing. And here, this function does not return anything. Another function, int return 5, in which we will simply return the value 5. Okay, let's not forget this is a function. Alright, so let's use these two functions, return nothing and return 5, in a program in the main. Let's, instead of printing these, we will print return nothing with an end line. And before that, let's try printing return 5, and line, and then try printing return 5 plus 2. Right. Now note that return nothing won't compile. So what is happening in here? Well, in the first statement, return 5 is executed. The function returns the value of 5 back to the caller, which passes that value to cout. Now, in the second statement, return 5 is executed and returns the value of 5 back to the caller. The expression 5 plus 2 is then evaluated to 7. The value of 7 is passed to cout. In the third statement, that won't compile. Return nothing returns void. Now, it is not valid to pass void to cout, and the compiler hence will give you an error when you try to compile this line. Now, one commonly asked question is, can my function return multiple values using return statement? The answer is no. Functions can only return a single value using a return statement. However, there are ways to work around the issue, which we will discuss when we get into the in-depth section of functions. Now let's go back to main. You now have the conceptual tools to understand how the main function actually works. When the program is executed, the operating system makes a function called to main. When execution then jumps to the top of main. The statements in main are executed sequentially. Finally, main returns an integer value, usually 0, back to the operating system. This is why main is declared as int main. Some compilers will let you get away with declaring main as a void function. So technically, this is illegal. When these compilers see void main, they will interpret it as something like int main and then return 0. You should always declare main as returning an int, and your main function should return 0, or another integer if there was an error. Now, in the return values subsection, you learn that a function can return a value back to the caller. Parameters are used to allow the caller to pass information to a function. This allows functions to be written to perform generic tasks without having to worry about the specific values used, and leaves the exact values of the variables up to the caller. This is a case that is best learned by example. So here's an example of a very simple function that adds two numbers together and returns the result to the compiler. We will call this add function. Let us delete these two and a bit of comments, or you know what, let's just write the function add int x int y. Return x plus y. Okay, in the main, we are going to print add 4, 5. Something like that. So, first of all, in the add function, the add takes two integers as parameters and returns their sum. As you can see in here, when function add is called, x is assigned the value of 4 and y is assigned the value of 5. The function evaluates x plus y, which is the value of 9, then returns this value to the caller. This value of 9 is then sent to cout to be printed on the screen, and as you can see, the output in my example over here was 9. Let's take a look at a couple of other calls to functions. For example, other than the add int x and y, let's create a function that returns the product of two numbers. Int multiply int x int y. Let's call these parameters actually z and w. Return z times w. So now in the main, using namespace std, we're going to add 4 and 5. Let's also add 3 and 6. Let us add 1 and 8. Then let's do something like int a equals 3, int b equals 5, cout add a, b, and line. Then cout, let's do something more interesting. Something like add 1, multiply 2, 3, and line. We will talk about this line in a moment. And cout add 1, add 2, 3. Then line, and then return 0. This program produces the output 9, 9, 9, 8, 7, and 6. The first three statements are straightforward. The fourth is relatively easy as well. Instead of placing in constants 3 and 5, we place in variables a and b. So, in this case, add is called where x equals a and y equals b. Now, since a equals 3 and b equals 5, add a, b is equal to add a 3, 5, which resolves to 8. Let's take a look at the first tricky statement in the bunch. That one. When the CPU tries to call function add, it assigns x equals 1 and y equals multiply 2, 3. Y is not an integer. It is a function call that needs to be resolved. Before the CPU calls add, it calls multiply, where z equals 2 and w equals 3. Multiply 2, 3 produces the value of 6, which is then assigned to add's parameter y. X equals 1 and y equals 6. Add 1, 6 is called, which evaluates to 7. The following value, 7, is passed then to cout. Well, the following statement looks tricky because one of the parameters given to add is another call to add. Well, but this case works exactly as the same as the one before, where the second parameter was a call to multiply instead of add. Now, before the CPU can evaluate the outer call to add, it must evaluate the inner call to add, which is add 2, 3. Add 2 and 3 evaluates to 5. Now it can evaluate add 1 and 5, which evaluates to the value of 6. Cout is passed the value 6. Now let's talk a bit about effectively using functions. One of the biggest challenges new programmers encounter, besides learning the language, is learning when and how to use functions effectively. Functions offer a great way to break your program up into manageable and reusable parts, which can then be easily connected together to perform a larger and more complex task. By breaking your program into smaller parts, the overall complexity of the program is reduced, which makes the program both easier to write and to modify. Typically, when learning C++, you will write a lot of programs that involve three subtasks. The first is reading input from the user. The second is calculating a value from the inputs, and the third is printing the calculated value. For simple programs, reading inputs from the user can generally be done in main. However, step 2 is a great candidate for a function. This function should take the user inputs as parameter and return the calculated value. The calculated value can then be printed either directly in main or by another function if the calculated value is complex or has a special printing requirement. Now, a good rule of thumb is that each function should perform one and only one task. New programmers often write functions that combine steps 2 and 3 together. However, because calculating a value and printing it are two different tasks, this violates the one and only task guideline. Ideally, functions that calculate a value should return the value of the caller and let the caller decide what to do with the calculated value. This is the end of lesson 1.3. See you next time.